Good morning, Geometry Honor students. So Mr. Chen again. So how are you guys doing today? And today we're talking about sections 11.1, 11.2. So the area of a sector and segments. And 11.1, it's pretty similar to what we were talking about before, which is the arc length. So let's just refresh the arc length formula. So based on the circle, so the way to find out the circumference of a circle is 2 pi r. Okay, so that's the way to find the circumference of a circle. So you want to find out the total distance of the arc length. Okay, so from point A back to point A, so 2 pi r, so with the radius. And the way to find out the arc length, so let's say that from point A to point B, right here. So you want to find out the arc length from this point all the way down here. So the way to do it, also based on the circumference formula, so it's 2 pi r times the measure of the central angle, m, over 360 degrees. So m, which is the central angle. Okay, so that's the way to find out the arc length. Another way to find it, it's by using r times theta. Okay, using r times theta. So the reason why that is because we want to convert the measure of the central angle to radian. So the way to do it, we multiply this entire quantity by 180 over pi. So as you can see that pi got cancelled, 2, 180, so that's 360, divided by 360, so that got cancelled. So at this moment, m turns out to be theta. Okay, so that's why it's r times theta. So this one is just a refresh with the arc length, and also with the circumference of a circle. So now the objective for that 11.2, so it's about finding the area of a sector, finding the area of a segment. So the area of a sector, so let's say that again using the circle from point A to point B, so I'm just redrawing it. So bounded with those two radii, so here's the area of the sector. So the way to find out the area of a circle is pi r squared. So multiply by the ratios. So m, which is the measure of the central angle, so m degree over 360. So you get the area of a sector. If you try to derive it by using the formula with theta, radian, so this one can be written as pi r squared times m over 360 multiplied by 180 over pi, just like the way that we convert the arc length with the radian. So pi got cancelled, 180 reduced with that 360, so this one turns out to be 1/2. And then at this moment, m turns out to be theta. So that's why what we got, it's 1/2 r squared times theta. If that's the formula, so that means theta, it's written in terms of radian, just like the arc length, so it's written in terms of radian. Okay, so now let's go to the next page and see the example. So find the area of each shaded sector. So let's just use the general formula. So pi r squared times m degree over 360. So what we found here is pi r radius, which is 4 centimeters, so 4 squared times m, 90 over 360. So reduce, so what we got here, it's 1/4. So pi times 16 times 1/4, so what we got here, it's 4 pi. Don't forget about the unit, so started with the length, centimeter, so the unit for this one, so square centimeters. Okay, so the other one is quite similar, so using that 80 degree, so well this time we need to subtract. Okay, so in order to get the measure of the other part of the central angle, so it's 360 minus 80. So that turns out to be 240. Well, let's see, wait, it's 280, excuse me. So 280 degrees. So pi r squared times 280 over 360. So pi times 5 squared. So 280 over 360, the 0 can be reduced, 28, 36. So let's divide the number by 4, so we got 7 over 9. Okay, so 25 pi times 7 over 9. And nothing we can reduce, so just multiply the number straight across. So 25 times 7, which is 175 pi over 9. And the unit for this one, again, square centimeters. Okay, so now let's see what else that we have. So the other one is finding the area of the shaded Y region. Okay, so in order to come up with that, the area of the shaded Y regions. Okay, so which is this part right here. Oops. Okay, so the shaded Y region. So this one is considered an inscribed circle. Inscribed circle bounded with the hexagon. Okay, so the first thing that we need to find out, it's the area of the hexagon. Okay, so that's something we'll talk about for the next section as well. Okay, so let's get the area of the circle. So we do know the base of the hexagon is 5 inches. So the way to find out the area of a hexagon is by using the formula 1/2 times the apothem times the perimeter of the hexagon. Okay, so the way to do it, so we need to figure out the apothem first. So one thing that we notice, so this one is a hexagon, the way to find out all the measure of the interior angle is n minus 2 times 180. So this one would be 6 minus 2 times 180. So 4 times 180. Which is 720. Okay, so 720 divided by 6. So we got 120 degree for each one of those interior angle. So that means this angle here is considered 60, 90, and 30. Because half of 120, it's 60. So using the ratio, so pull this out, the right triangle. So we got 30, 90, 60. So using the special ratios of 30, 60, 90 degree triangles, so half of 5, which is what, 2.5. And then 60, so we want to get the apothem right here. So that would be 2.5 times root 3. Okay. So 1/2 times 2.5 times root 3. And the perimeter of this hexagon, so each side length it's 5 inches, so 5 times 6, which is 30. So 30 divided by 2, 15. 15 times 2.5 root 3. Okay, so this one, let's find out what that is. So 2.5, or this one you can just say that is 5 over 2. 5 root 3 over 2. So 15 times 5, 75 root 3 over 2. So that would be the area of this hexagon. And then the circle, so we do know that the diameter of the circle is 5 inches. Okay, so we try to extend it all the way through. Okay, so that it's the diameter of the circle. Okay, so take the radius, so which is 2.5. So pi r squared to get the area of a circle. So pi times 2.5 quantity squared. So 6.25 pi. So this one is being bounded with the area of a hexagon and the area of a circle, so we subtract. So 6.25 pi subtracted from 75 root 3 over 2. So that's how we get the area of the shaded region. Okay, so now let's see what else that we have for this one. So find the figure's area. So now the next one we just want to talk about, it's the area of the segment. So let's say that we do have a circle. And this one is being bounded with the area of a sector, the triangle here. And then the segment would be from point A to point B, and you want to find out this shaded region. So the way to do it, so usually the formula, it's the area of a sector minus the area of the triangle. So we can get the area of the segment. Okay, so the area of a sector, which is what? Pi r squared times m degree over 360. And then the area of a triangle, 1/2 times base times the height. Okay, so this one, just like an egg. Okay, so the one that we want to find out, it's the shaded region, the area of the shaded region. So imagine that this one, it's the area of a sector. So for the triangle, okay, so it looks like this one is an equilateral triangle. So the area of a triangle, okay, so this one kind of like a y-axis, the x-axis, if I try to extend it all the way through. Okay, without the x-axis. So this one is actually being bounded with the area of a triangle and the area of the sector of the circle. So imagine that this one, it just the center of the circle. So this one is 60 degrees because that's an equilateral triangle, which is the same as equiangular. So each angle is 60 degrees. So the radius is being bounded with this segments, so R and R. So it's kind of like a cross section here. So what we can do, so let's find out the area of the sector first. So the area of the sector, so then that'd be pi r squared times 60 degree over 360. So pi times 20 quantity squared, so 60 over 360, so then that'd be 1 over 6. So 20 squared, so 400 pi over 6. And then this one, obviously, it's reducible by 2, so 200 pi over 3 square centimeter. And then in order to find out the area of a triangle, so this one, it's a equilateral triangle. So base times the height, so the height, using that the special ratios, 30, 60, 90. So half of the base is 10, so this one will be 10 root 3. So area of the triangle, so 1/2 times 20, so the height, which is 10 root 3. So 1/2 times 20, then that'll be 10. 10 times 10 root 3, so it's 100 root 3. So once we get that, and then we can get the area of the segment. So the area of a segment, which is the area of a sector minus the area of a triangle. So 200 pi over 3 minus 100 root 3. And then we do have 3 of those because that this one, and this one. So we multiply by 3. Okay, so 3 times the quantity of 200 pi over 3 minus 100 root 3. Okay, so the shaded region. Distribute, so we do have 200 pi minus 300 root 3. Okay, so then that'd be the area of the shaded region. So for the last 2 problems, so they're a little bit complicated, so please, so just rewind or fast forward to the part of the content that you're having a hard time to deal with. So just watch that again. Okay, so again, the basic formula, area of a sector, and then also the area of the segment. Okay, so thank you for watching the video today. So I'll see you guys next time. Have a great one.